Hi everyone. Now that we built up all this notation about integrals, I thought that it would be good to take a minute to go through kind of three different things that you'll see and clarify what exactly you're getting from each of those three things. So you really want to try and have this in your head. We use this big script S to represent integrals, but they can be definite, they can be indefinite, or they can be this new, looks like a definite integral, but there's a variable in it that we're getting from the second fundamental theorem of calculus. So this first one is a definite integral. And in terms of what we're going to get from that, we should be getting a number. And that number represents the area trapped under the curve, f of t, from 3 to 51. So we don't really know what this looks like, but say it's going along, and this is 51, and this is 3, and this will give us the numerical value of that area. There's some subtleties. If your curve goes below the axis, then it's sum and difference of areas. But this idea that that represents a number, and the number is tied to information about area trapped between little f and the t-axis in this case. The indefinite integral does not give us an area. It gives us an antiderivative. In fact, I'm saying that wrong. It gives us the antiderivative. So the entire family of functions that could be an antiderivative of little f of t, meaning this includes the plus c. So it gives you a big F of t plus c, and this is the entire family of antiderivatives. So it's not just a single function, it's all the functions, that plus c differentiating between different ones, all the antiderivatives of little f of t. Okay, and last but not least, this one that looks like we're getting a definite integral but has that extra variable. This one will give us a function, a single function, so it gives us one antiderivative. And it's a very specific one, and this lower limit of integration determines basically which plus c is involved in this one, right? So that fixes a single point on the graph. But weirdly, a lot of times people think of that plus c as being connected to their y value. I guess it's really connected to all y values. But that 3 tells us about an x-intercept. So this is one antiderivative, and it happens to be the one that goes through the point 3, 0. And I know that because if x equals 3, then we've got a 3 up top here, and it doesn't matter what the function looks like. If you integrate from 3 to 3, you're going to get 0. So we're getting the specific antiderivative function that goes through the point 3, 0. So again, the first one, you should expect a numerical answer. The second one, you should expect the entire family of antiderivatives. And the third one is giving you one very specific antiderivative. So hopefully that helps clarify. Try and kind of keep that straight in your head so you're realizing what kind of answer you're going for each of these questions. Thanks for watching.